The flyback converter is an isolated DC-DC converter, and its operation can be divided into two main stages. Alternating current oscillates as a sine wave. During the positive half cycle of the voltage, current flows through diode D1 and exits through diode D3. During the negative half cycle, current enters through diode D2 and exits through D4. This process organizes the AC into a unidirectional pulsating DC. The rectified voltage is then smoothed by a large capacitor, much like adding a reservoir to pulsating water flow, resulting in a steadier DC output voltage. When the MOSFET switch turns on, the rectified and filtered DC voltage is applied to the primary winding of the transformer. At this point, the primary winding behaves like an inductor, with current flowing from the top end, through the switch, and out from the bottom end. Over time, the current increases and magnetic energy is continuously stored. This phase is crucial as the transformer acts like a battery being charged. Meanwhile, the secondary side diode is reverse biased and does not conduct, leaving the output capacitor to supply the load on its own. When the MOSFET switch turns off, the primary current is interrupted, and the magnetic energy stored in the transformer begins to release. The secondary winding generates a voltage, and the diode conducts. Energy transfers from the primary to the secondary side, charging the output capacitor and supplying the load. This is where the flyback converter gets its name. The current direction on the secondary side is opposite to that on the primary. This process is akin to the battery discharging, with the duration depending on the amount of stored energy. Features of flyback converters: simple structure and low cost, suitable for low-power applications. The primary and secondary windings are connected in reverse, enabling step-up or step-down operation. Output voltage can be controlled by adjusting the duty cycle. The transformer simultaneously serves as an energy storage and voltage conversion component. This topology is widely used in various low-power applications, such as phone chargers and LED driver power supplies. Now that we've understood the working principle of the classic flyback circuit, let's explore a 100-watt PD fast charging solution. This is a high-cost performance dual-port USB PD power solution based on a three-stage topology. AC/DC stage uses a CRM-controlled PFC circuit with a 650V/180 mΩ superjunction MOSFET. DC/DC stage adopts a QR flyback topology with a 650V/270 mΩ superjunction MOSFET on the primary side, paired with a 40V/5.5 mΩ SGT MOSFET for synchronous rectification. Output stage utilizes a dual-channel synchronous rectification buck circuit with 30V/4.8 mΩ SGT MOSFETs, achieving a peak system efficiency of 94.8%.